So today we're gonna discuss this problem from the AtCoder Beginner Contest 152, Problem D, Handstand 2. So in this question, you are given a positive integer n. Find the number of pairs AB of positive integer not greater than n that satisfy the following condition, in which when AB are written in base 10 without reading zeros, the last digit of A is equal to the first digit of B and the first digit of A is equal to the last digit of B. So you are actually have to form two pairs, like pairs in which these two numbers are such that the first digit of A is equal to the last digit of B, last digit of B is equal to the first digit of A, and you have to find out how many pairs are there. So till n. So if you write till 25, you can say 1 1 is there, 1 1 2 2 2 22, and so on. And so the answer is 70. So how you can find out? Though it fits, like seems pretty complex, but if you understand the logic, it is more clear. So what you can do is, because the number are up to 10 to the power 5, you can iterate over every number and you can find out the first digit and the last digit for every number. Okay, and you can form a grid because every number will be either 0 from 0 till 9. Okay, so now what we are actually doing here is I have only taken out some of the numbers, and like like you can go up to 25, or like how many, like the constraints. Well, I have to explain it, so I have taken only small numbers. So this will go up to n, but I have taken only these numbers from 11 to 21. So you can easily find out the first and the last digit. You can do a while loop, first find out the first digit, and then do a while loop until the last digit and take out the last digit. So now you can know that the first digit is 1 and the last digit is 1. So if you assume these are for the first digit and these are for the last digit, you will mark this as 1, or everything is 0, you will like increment this by 1. Then the first digit is 1 and the second digit is 2. So then you will increment this, and so on. Everything is 0, I hope you understand. 20 will be the first digit is 2, second is 0. Then 21 is this, 20. Okay, so if there is number such that 101, then it will be counted as the first digit will be 1, last digit is 1, so it will be counted here. If it is something like 201, so it will be counted as 21 only. So the first digit is and second digit is 1, so it will be incremented at 2. So now we want to find out how many pairs are there such that the first digit is equal to the last digit of both, like of both the numbers. So let's take the example of these two. These two will form a pair with this. So for every number of this category, 1, 2 will form a pair with all the numbers such that it will be 2, 1 or 201 or a number which starts with 2 and ends with 1. So for every number we can pair it with this or any number which starts at 2 and ends at 1. So if there are like n numbers of this type in which starts at 1 and ends at 2, and there are m numbers of this type in which it starts with 2 and ends at 1, we will just multiply them, because for every number we can pair it with all those m numbers. For every n, or like for every one number of this type, like this type, we can pair it with all those m numbers. So all the n numbers will pair with all the m numbers, and we can do the answer, find the answer. So all the n numbers of this type is stored in this. All the m numbers of this type is stored in this 2, 1. So how we can find the answer? We just have to multiply them. So for every digit, like for every iteration, for every value, what we can find out is actually we will multiply it with, so if this is ij, we will multiply it with ji, just opposite. And as you can see, 11 1 and 111 are considered different. These two are actually taken out separately. So for every ij, what we will take is we will multiply it with a gi for every value from this to this, and we will find out whether all those number exist, because everything, if only one pair is this and nothing, this is 2 2, it will multiply with 2 2 only. But if the number is 1 2 and there is no 2 1, then it will not be multiplied with anything and it will be 0. So that's a simple logic. So I'll tell you how the code goes. So we'll first take the input of all the n, which is the upper bound till which we have to do the loop. We will make this table. We will run our loop from 1 till n, and then we'll first find out the right. Right means this number are denoted by right, the rightmost number, and the left are denoted by left, leftmost number. So right is just we take the modulus of this number with 10. The left is we'll first take the number I into num, do a while loop, iterate it, and when we come out of this loop, we'll know that k actually stores the last number, because k do a modulus of n and then we divide it by 10. So for every number we'll store the number in k. So L will become k when we iterate over the whole number, and we will do a plus plus on this vector in C of L and R, and then after that we'll take the long num total finding on all the pairs. We'll iterate from 0 to 10 for all the values from I to j, and the total will be plus equal to C of ij into C of ji, and the answer will like the output is 2. I hope you understand the logic as well as the code. If you still have any doubts, please mention now. Thank you for watching this video. I'll see you next one. Bye.